Proving triangles congruent. By definition, two triangles are congruent if corresponding angles are congruent and corresponding sides are congruent. Because of this, the definition requires that we know 6 congruences, 3 pairs of congruent angles, and 3 pairs of congruent sides to assert two triangles congruent. Fortunately, like with similar triangles, there are shortcuts that allow us to assert two triangles congruent with less information. Third angle theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles are also congruent. So given that angle A is congruent to angle D, and angle B is congruent to angle E, prove that angle C is congruent to angle F. So it's given that these angles are congruent. Therefore, the measure of angle A equals the measure of angle D, and the measure of angle B equals the measure of angle E, because that's the definition of congruent angles. We also know that the measures of angles A, B, and C add up to 180 degrees, and the measures of angles D, E, and F also add up to 180 degrees, because that's the triangle sum theorem. Since we already determined that the measure of angle A equals the measure of angle D, we can replace A here with D, and we've already determined that the measure of angle B equals the measure of angle E, so we can also replace angle B here with angle E. So this is just some substitution so that we can get the measure of angle D plus the measure of angle E plus the measure of angle C equals 180 degrees. And we still have this same line here. That hasn't changed at all. But this is the substitution property. If we were to set these equations all equal to each other and then subtract everything out, we would have this one subtracting this one, so these two would cancel out. This subtracts this, those cancel out. 180 minus 180 cancels those out to 0. So we get, finally, the measure of angle C minus the measure of angle F equal to 0. That is the subtraction property of equality. And if we then add the measure of angle F to both sides, we get the measure of angle C equals the measure of angle F, because that's the addition property of equality. And because the measures of these angles are equal, that means that the angles are congruent, because that's the definition of congruent angles. And here is the full proof of the third angle theorem. Properties of equality and congruence. These properties are presented again as review. These properties will be used regularly in triangle congruence proofs. The properties of equality, where A, B, and C are numbers. Reflexive property of equality, A equals A. Symmetric property of equality, if A equals B, then B equals A. Transitive property of equality, if A equals B and B equals C, then A equals C. Substitution property, if A equals B, then B can be substituted for A in any expression or equation. The properties of congruence, where A, B, and C are geometric figures. Reflexive property of congruence, A is congruent to A. Symmetric property of congruence, if A is congruent to B, then B is congruent to A. Transitive property of congruence, if A is congruent to B and B is congruent to C, then A is congruent to C.